It's early 1943 on an island called Peenemünde off Germany's Baltic coast. Here, in extreme secrecy, a new weapon has been developed. It's a rocket theoretically capable of reaching Britain from German soil. When it's perfected, it will wreak havoc in Europe and England. But as a weapon, it will not kill as many people as the number of concentration camp laborers who die in the process of producing it. And when the war is over, it will become a major tool in America's conquest of space. The Smithsonian Institution's National Air and Space Museum is the most visited museum in the world. Its collection contains some of the most important aircraft and spacecraft in history. Craft that were designed, built, and flown by men and women who have expanded the frontiers of flight. On March 16, 1926, in Massachusetts, Dr. Robert Hutchings Goddard launched the world's first liquid-propelled rocket. For most of the next 15 years, he developed his designs, building and launching 35 rockets, pursuing his dream of a rocket big and powerful enough to explore outer space. Throughout the 1930s, while Goddard worked alone, German rocket engineers, also pursuing the goal of space travel, were employed by the military, who funded the development of a rocket similar to Goddard's in principle, but a great deal larger. Their efforts eventually led to the development of the V-2, Hitler's wonder weapon. With 1 ton of explosives packed in its nose cone, it caused a sensation in the late years of World War II. This is the story of the rocket pioneers of 2 continents and their efforts to achieve the goal of space travel. In the late 1920s, experimenters in America and Europe investigated uses for solid fuel rocket power. They weren't always successful, but many persevered in spite of the difficulties. One of the problems was achieving a burn that could be controlled. But visionaries in Russia, Germany, and America believed the rocket was the key to leaving the Earth. Russian schoolteacher Konstantin Tsiolkovsky dreamed of exploring space.
Inside the Soviet Union, he was a real important character. The Bolsheviks discovered him very early on and sort of identified him as a hero of the people, this inventor who had been downtrodden and forgotten and pushed into the background was a man of the people, and he represented the kind of forward into the future thinking that they wanted to encourage.
In 1903, the self-taught Tsiolkovsky published his article, Investigations of Space by Means of Rockets. 20 years later in Germany, the work of another rocket visionary, Dr. Hermann Oberth, was published. It was a book called The Rocket into Planetary Space. It demonstrated mathematically that rockets had the potential to take man beyond the reach of Earth's gravity. Oberth was born in what's now Romania. When he went to Germany, he became the focal point of a group of rocket experimenters who in just over a decade would succeed in propelling a rocket beyond the Earth's atmosphere. When Robert Hutchings Goddard published this paper in 1919, he was 37 years old and assistant professor of physics at Clark University, Worcester, Massachusetts. As a boy, he had thought about space travel, and in a graduation speech, he told his classmates, "The dream of yesterday is the reality of tomorrow."
They were literal visionaries. When Goddard was 16 years old, his father asked him to go out into the backyard of the house in Worcester, Massachusetts, and trim the top branches in a cherry tree. And he'd been reading War of the Worlds, H.G. Wells' novel that had been serialized in the Boston Post. And he got up on the top of the tree, and essentially he had a vision. He says he could imagine what it would be like if a spacecraft would come down and land in the meadow at his feet. And he says he could imagine the object swinging around that was powered by centrifugal force. And he says, when I climbed down from that cherry tree, I was never the same after that.
In 1919, a few of Goddard's ideas on space reached the press, and he was seen as an eccentric scientist. He realized that liquid fuels could be controlled for sustained power and wrestled with the problems of combining gasoline and liquid oxygen. He searched for a metal that could stand extreme temperatures, and he experimented with ways to ignite the propellants without causing an explosion. Goddard was forced to move his experiments to Aunt Effie Ward's farm outside Worcester. There had been complaints about the noise. In 1926, he bought his wife Esther a movie camera to film his flights. It was hand-wound and only ran for 7 seconds. When his liquid-fueled rocket rose 41 feet on March 16th, the camera ran out. Esther missed recording the world's first successful liquid-fueled rocket flight. By 1926, Goddard had been receiving small grants from the Smithsonian Institution for 9 years. He wanted to build a rocket that would carry 20 times more propellant than the earlier one. The Smithsonian wanted impressive results. On the first test, the gas tank blew up. Goddard made changes, but by the end of September 1927, after many failures, he decided he'd been too ambitious. A model only 4 times larger than the 1926 version was more feasible. Regarding each unsuccessful test as a means of learning something positive, Goddard, his assistant Henry Sachs, and the rest of the team pressed on through 1928 with more work and more tests. They were working to try and improve combustion, and through the summer achieved some encouraging results. But as the tests at Aunt Effie's farm continued into fall, a variety of failures increased Goddard's notoriety in the Worcester area. It was highly experimental work. No one really knew what would happen next. Goddard remained in Worcester through the fall of 1928, working on a new design. As in one of his earlier models, the combustion chamber and nozzle were at the top with the gasoline tanks. The 2 liquid oxygen tanks were below at the sides. It was called the hoop skirt model, and in this test on October 20th, the hoop caught on the launching tower. Tests on the new design continued into winter with some small successes. Goddard and his assistants spent the day after Christmas fighting yet another fire in Aunt Effie's pasture. Events like this enhanced Goddard's notoriety as the Moon Rocket Man and increased pressure for him to move away from harassment by the fire department and interested spectators. In the early 20s, Dr. Herman Obert wrote to Goddard suggesting they pool their knowledge, but Goddard wanted to work alone. In 1928, Obert moved to Berlin to work on Fritz Lang's film Woman in the Moon. He was supposed to build a real rocket as publicity for the movie. There were technical problems and difficulties with government officials about a location for the flight. The project was abandoned. But Obert's involvement in German rocketry was by no means over. He was elected president of the Society for Space Travel. The society was formed in 1927 to raise money and support for rocketry. Obert's vision impressed many young Germans.
Obert talked about space stations. Robert came out of a family of a medical doctor. His dad was a medical doctor, so he worried about the effects of rocketry on the human body. He worried about zero gravity once you are in orbit, and he clearly recognized that under that condition you are under zero gravity. Many people did not believe it. Many people did not agree with him.
While working on Fritz Lang's movie, Aubert employed Rudolf Nabel as his assistant. Nabel was an engineering graduate and ex-fighter pilot with a talent for self-promotion. He was a rocket enthusiast whose real contribution to the Society for Space Travel was in securing an inexpensive lease on an old ammunition dump at Reinickendorf, on the northern outskirts of Berlin. It became known as the Rocket and Flugplatz, or Rocket Aerodrome, and for a time was the focal point for rocket enthusiasts in the Berlin area. One of the people who came there regularly in 1930 was a teenager called Werner von Braun. He was one of the youngest members of the group, but within 2 years would control its destiny. Werner von Braun was born in 1912. He was the son of aristocratic East Prussian landowners and was a privileged and gifted child. He played the piano and composed music. This fantasy was written when he was 16. But music was not his prime passion. From an early age, von Braun's obsession was outer space. This is a school essay on astronomy in the solar system he wrote when he was 15. He wrote another that includes a cutaway design for a rocket-powered spaceship.
He wanted space travel, he wanted to build rockets, and he did that already as a boy. He was 12 years old, and that was all along, and he wanted to put a station in orbit and go to the moon.
On July 25, 1930, Robert and Esther Goddard arrived in New Mexico after a 10-day drive across the United States. Their move was made possible by a grant from Daniel Guggenheim. Charles Lindbergh, an admirer of Goddard's work, convinced Guggenheim to give Goddard $25,000 a year for the next 2 years. The Goddards planned to live in Roswell in southeast New Mexico, and with 4 assistants and their families, rented the Mescalero Ranch, 3 miles from the town. At Eden Valley, 10 miles from the ranch, Goddard found a site from where he could launch his rockets. It gave him the privacy he'd always craved, and it was rent-free. Goddard had chosen Roswell because its climate is suitable for launching rockets at any time of the year. The old windmill he'd used as a launching tower back in Massachusetts had been brought to New Mexico, and soon its 60 feet rose above the Eden Valley prairie. At the Mescalero Ranch, Goddard's 4 assistants built a workshop. A short distance away, they assembled a stand for static engine tests. The rocket was held in place and hooked up to instruments that measured thrust and fuel burn efficiency. When Dr. Goddard was convinced that all the rocket parts were working properly, it was taken to the launch site and placed in the tower. When the rocket was fueled, they ran an electric cable out to the shelter, 1,000 feet away. After a final check, the remaining crew members and the doctor himself made the best speed they could to the waiting automobile. At the 1,000-foot shelter, an assistant climbed a ladder and checked the pressure through a telescope. Then, while the doctor watched through binoculars, the rocket was fired. On the second last day of 1930, the rocket known as Nell rose 2,000 feet above the prairie. It was a good beginning for the Goddard crew. Meanwhile, across America, many young people were beginning to experiment with rockets. Among them was a boy called Bob Truax.
I had a friend who was also interested in rockets, and he built a very beautiful balsa wood rocket, and together we loaded it full of smokeless powder, which we pried out of shotgun shells. Of course, we blew the rocket to smithereens. He went off to build another rocket, and I went back to the library to figure out a better engine that wouldn't blow up. Turns out you can do that. They had precise instructions for building black powder rockets, so I learned how to mix black powder, and I mixed it in the basement, and my mother never knew I was doing it down there.
German rocket pioneers, like rocket pioneers all over the world, needed money for their experiments. Reinhold Tilling thought up a novel commercial application that didn't ever really catch on.
Germany has a number of islands along the North German coast in the North Sea, and also some larger islands in the Baltic Sea. And during bad weather, of course, there was no communication at all. And we proposed to use rockets, even in bad weather, to shoot them. The rockets had unfolding wings on the side, and at the peak of the trajectory, they would unfold their wings, and then they would glide into the receiving area, carrying quite a bit of mail on board.
To some observers, a rocket gliding to Earth with a nose cone full of letters and postcards was the idea of a crackpot.
Even Werner von Braun said, a man is just a crackpot until he hits the jackpot. And I think that's somehow typical, and that's absolutely true. And most people, of course, thought we were just playing around with things. Many people did not see an application.
Practical application was the key to financial support for rocket development, even if space travel was the ultimate goal. In October 1932, Winkler's liquid-fueled HW-2 rocket crashed during a demonstration to the German Navy.
I think all the people basically had space flight in mind as a long-range goal. Of course, I think all the people realized that you need so much energy to really go into outer space that you had to go through a number of intermediate steps first. And I think that was the main reason that we pushed postal rocketry. We saw a revenue source in that area, and that was, of course, always our big problem. How do you fund, how do you pay for all these things?
The German Army Weapons Department offered one answer to that question. Rockets were a potential alternative to heavy artillery, which was reaching its limits in range and payload. In Berlin, the Rocket and Flugplatz was visited by representatives of the Ballistics and Munitions Branch, including Captain Walter Dornberger. By 1932, they had established an experimental rocket station at Kummersdorf, south of Berlin.
He was a doctor engineer. In other words, you couldn't tell him anything what wasn't true. He was a human being, a very fine man. And he really was nice to everybody, especially the older people. He knew them for so many years. And while I was in Kummersdorf, he came at least once in the week. He was out there.
The prize recruit from the Rocket and Flugplatz was Werner von Braun.
He realized the only way to get really major amounts of cash is if you can get an institution like a government behind you. And I think that's why he readily accepted his work for the army.
Von Braun was still only 20 years old. He was appointed as Dornberger's technical assistant and sent to Berlin University to gain his doctorate in physics.
Well, some people agreed with von Braun, and some people, together with von Braun, after he was a first employee working for the German army, he got some other people over. But a number of other people thought, and they probably deducted already, that they really wanted to use a rocket for military purposes. And some people did not go along with it, and some people did not join von Braun in Kummersdorf for that reason.
By this time in America, a number of groups were forming to experiment with rockets. In New York, attempts were made to fly this rocket airplane, but other more visionary organizations, like the American Rocket Society, set their sights on space travel. And all the while, boys like Bob Truax continued their own personal experiments.
I finally graduated from black powder to smokeless powder because I found that at the University of California, the Extension Division would clean out their old movies. In those days, the movies were based on nitrate film, which is basically smokeless powder. And I could go into the garbage cans out and back and get the reels and reels and reels of old nitrate movie film, which made a marvelous rocket propellant.
In September 1934, Robert Goddard returned to Roswell after an absence of more than 2 years. The Depression had forced Harry Guggenheim to terminate Goddard's funding in 1932, but he'd just been given a new grant of $18,000 for 1 year of successful full-flight demonstration. The launch tower was updated, and Goddard continued his experiments with gyroscopic control. Here he demonstrates a gyroscope by using a handheld bicycle wheel and a swiveling seat. His objective was to develop a control system for his new A series of rockets that would keep them heading straight up until fuel was exhausted. A gyroscopic stabilizer was designed to fit the rockets. The rocket also used nitrogen gas pressure to operate vanes installed in the path of the rocket exhaust. The flight of March 8, 1935, used the pendulum stabilizer and a fully streamlined casing. The gyro stabilizer had been damaged in an unsuccessful flight in February and was being repaired. It wasn't perfect, but the parachute worked reasonably well, and the results were promising enough to cause excitement among the doctor and his colleagues. After 2 years without funding and a current agreement for only 1 year, Goddard was well aware of the need to impress his benefactors with evidence of progress. With the gyroscopic stabilizer repaired, another flight was made on March 28th, but again the rocket was damaged. It took 2 months to repair, but the flight of May 31st was worth the delay and the effort. Controlled by the stabilizer, the rocket rose straight up to 7,500 feet. In July, another flight was made to an altitude of 6,600 feet. Goddard had a reputation for being secretive about his work. He always wanted to operate alone, and he'd resisted making displays for public relations purposes, even when continued funding depended on impressing people who controlled the money. But after the successful flights of May and July, he had the opportunity to put on a show for his benefactors. He invited Charles Lindbergh and Harry Guggenheim to visit Mescalero Ranch. He prepared 2 rockets for the demonstrations. Although Lindbergh had visited Roswell, he had not seen a rocket flight or even a static engine test. Neither had Harry Guggenheim. Unfortunately, that was the way it was to remain. Lindbergh and Guggenheim arrived in Roswell in September. Neither of the 2 rockets prepared by Goddard worked. Lindbergh and Guggenheim were sympathetic, but they left Roswell without seeing any tangible evidence of Goddard's progress. The flights of May and July confirmed Goddard as a leader in liquid-fueled rocket technology. But as he continued testing into 1936, at Kummersdorf in Germany, developments that would soon leave him far behind were underway. As early as 1934, the German A-2 had reached heights similar to those just achieved by Goddard. Now a new super rocket, the A-4, was being planned. In early 1936, Colonel Dornberger and Werner von Braun discussed the design and building of a rocket about 40 feet long. It would be a weapon with a range of at least 160 miles, and its speed at burnout should be 3,600 miles an hour. Before it could be built and tested, a facility very different from Kummersdorf would have to be established.
The Army saw very clearly that the tests for bigger and bigger rockets could not be continued in Kummersdorf. So they were really looking for an area, for a launching area, which firstly was isolated, so that no large amount of people were living close by. And von Braun saw also from the beginning that you really should have a launch site at a major body of water, so that you can launch your rocket over water, where normally not too many people are present all the time. And he also wanted to have it along the coast, so that from the coast you could observe your trajectory by theodolites, by photographic equipment. And that was the basic reason for the selection of Peenemünde. Peenemünde is located on an island, the island of Usedom. The Peene River separates the island of Usedom from the mainland. And there was a harbor available, so you could, with relatively heavy equipment, get into the area.
To develop the A-4, as the rocket was initially called, von Braun convinced some old friends and many talented newcomers to join him. Klaus Riedel, his wife Babs, and the brilliant young Walter Thiel and Hans Hoyte were among those who trusted von Braun's vision and leadership and moved to Peenemünde.
Von Braun, he was the only one I ever met in my whole life who was a perfect man. There are a lot of times when some people had enough and we had all failures and want to quit, and he always talked them in, and that we get there where you think we should go.
The A-4 was to be a highly complex piece of machinery. As a weapon, it needed to be accurate. It would have a gyroscopic guidance system in the nose cone. Just below that would be the liquid oxygen tank. Unlike Goddard's rockets, which used gasoline, the A-4 would use ethyl alcohol. The key to this rocket would be the turbo pump, which would feed a steady stream of propellants into the combustion chamber, producing a thrust of more than 50,000 pounds. In 1936, while the resources of the German military were harnessed to establish a new rocket base at Peenemünde, Goddard and his small crew worked on in isolation at Roswell. Goddard was beginning what he called his L series of experiments. So far, he'd used nitrogen gas to pressure feed fuel into the combustion chamber. Now he was developing a much larger rocket. A proportionally larger nitrogen gas tank would be too heavy. But if he used liquid nitrogen instead of the gas, he could install a smaller and lighter tank. By now, Goddard had been coming to Roswell for 6 years.
Roswell knew of a fellow out there shooting rockets, but some thought he was going to hit the moon, or, didn't think too highly of it. But others could see, he was trying to develop a power plant to do this thing, go planets or whatever.
Goddard remained secretive about his work, but while the Roswell townsfolk might gossip, they didn't pry. For their part, Goddard and his wife Esther had some involvement in the affairs of the town.
They were both involved in the community affairs, like he was with, I see, was it Kiwanis? Yeah, I think so. And went to church occasionally, but he could get wrapped up in his work, and the rest of it didn't matter too much. So he took the bumps along with the good stuff. Had to, because he had a lot of bumps. Yeah.
Young Bob Truax had heard of Goddard's work and was curious about his progress.
I wrote him a number of letters, got nothing but form replies, and I read everything that was in the library on his experiments, which I found very annoying because they had no figures in them. I said, what kind of performance is he getting? I don't know. He wouldn't tell anybody. But they were very readable and had some nice pictures in them, so.
The L-series tests did not begin well. The combustion chambers kept burning through, and attempts to use 4 small motors instead of 1 large one failed. Goddard reduced the diameter of the rocket, and in the spring of 1937 had several successful flights, including one to a height of almost 9,000 feet, his best result yet. On May 19th, he successfully flew a version with retractable steering vanes at the base of the rocket. Apart from getting his rockets to fly, Goddard's other problem was to get his parachutes to work so they would save damage to the rockets on descent. There were many parachute failures. Charles Lindbergh now suggested that Goddard contact the National Aeronautic Association to have representatives come to Roswell and verify his successes. Goddard reluctantly agreed. 3 military observers were appointed, but on the day in June 1938 when the first demonstration flight was planned, a tornado struck Eden Valley and severely damaged the launch tower. Within 2 months, repairs were made, and a flight to 6,500 feet was officially observed and recorded. By this time, Bob Truax had moved to Annapolis, Maryland as a midshipman trainee at the Naval Academy. He pressured the officers to allow him to experiment with rockets.
When they first made a decision to give me permission, Captain Cox, who commanded the station, had gotten all the heads of departments together, and I had to give them a briefing on what I intended to do. They asked me a lot of questions. Well, it's going to blow up. No, I said, it won't blow up. Now, this is made of nickel steel, and it's a half-inch thick, and it's the stress level on that is so and so and so and so. And I had the facts and figures at hand. And then the head of the internal combustion engine laboratory, he said, well, rockets are no good anyway because they won't work out in space. There's nothing to push against. Well, I had him there. There I really had him because that's a very popular misconception, but dead wrong. And I said, well, now, wait a minute. This works on Newton's second law of motion, action equals reaction, conservation of momentum, and so on. You create momentum in this direction, you're going to get momentum in that. And at this point, Captain Cox began to chuckle. And he said, well, fellas, what do you say we give him a crack at it? And they gave me an assistant, and they gave me some money so I could draw materials and this sort of thing. And I realized rather early on you weren't going to design a rocket, build it, and fly it all in one stage. So I built a combustion chamber, nozzle combination, and a stand on which to test it.
When he graduated in 1939, Truax was asked to meet with one of the officers. He thought he knew what it was about and went prepared.
He said, tell me, could you make a rocket that would help a heavily loaded seaplane off the water? And I said, well, I just happen to have a little analysis of this in my hip pocket. And I said, well, now, if we had about so much propellant and so much, we could get about so much extra payload and so on. Great. In fact, I had a drawing of a rocket that would do that. He said, go out to the fleet. He says, write us a letter. And he told me basically what to say. And we'll use this as a vehicle to get you ordered back to duty here.
Robert Goddard faced a problem that von Braun had been working on since 1935. In a really large rocket, pressure-feeding fuel is not a good option. Pressure tanks that are strong enough are too heavy. You need an effective fuel pump. From 1938 to 1940, Goddard worked to develop a turbo pump for a new large rocket. Goddard began testing the turbo pump for his P-series rockets in early 1939. The mixture of liquid oxygen and gasoline could give spectacular results. Goddard's turbo pump used a boiler to vaporize some of the liquid oxygen. The hot oxygen gas drove a small turbine. The turbine drove pumps that forced liquid oxygen and gasoline into the combustion chamber. The pump for the big P-series rockets took a long time to develop. It was the most difficult technical challenge Goddard had faced throughout his long career. The first P-series rocket wasn't ready to fly until August 1940. On the first test, the fuel tanks burst and ignited. At about this time, a young Roswell man, George Bodie, called on Dr. Goddard and asked for a job. He was put to work in the shop doing a little welding and learning the rocket business. More than 50 years later, at the launch site at Eden Valley, George Bodie recalls his impressions of the time.
Mostly it was the excitement of setting it up and then hoping it would go, you know, because that was a big deal, yeah. Of course, failures were kind of scary too, because you're only about 1,000 feet away from it. One time it went up and it actually circled down and came pretty between the tower and the thing within about 300 feet of them, so that was close enough. It fired up normally, and then it started up in the tower, but then it hung up for some reason. I don't know whether when the catches didn't let loose, and then after it ran a little bit, why, one of the pumps blew up, I think. Of course, then they'd wait a little bit, and then we'd run up and throw sand on it or something like that. But with liquid oxygen, you had to be pretty careful because it was pretty explosive, you know.
In April 1941, Bob Truax returned from 2 years at sea. He put together facilities and staff to develop a rocket-assisted takeoff system for the Navy's consolidated PBY Catalina flying boats. Truax was not the only American working on JATO, as the assisted takeoff system was called. Dr. Theodore von Karman and his Jet Propulsion Laboratory staff at Caltech were successfully testing a solid-fuel JATO. While Bob Truax was still at the Navy's Bureau of Aeronautics setting up the Annapolis JATO research facility, Dr. Robert Goddard came to see him.
He came in and he told me that the Guggenheims were encouraging him to offer his services to the government. And I told him that as far as I had been able to ascertain, the only interest within the government was for assisted takeoff. I think I'm the guy that many people say turned him down. To my knowledge, he wasn't turned down, certainly not in my department, and he wasn't laughed at, and he wasn't sent away. Well, he was sent away empty-handed, but definitely told that in this one area, at least, we had an interest and give us a proposal.
By December 1941, Goddard was running JATO units in the test stand at Roswell. It was the first time Goddard needed to consider the safety of a pilot. Just days after his first successful test, Japan bombed Pearl Harbor, and America entered World War II. By July 1942, Goddard was living on the Chesapeake Bay and working at Annapolis full-time on his JATO system.
In essence, through the war, we worked pretty much, well, we worked side by side. I don't know, as you'd say, we worked together. We were in some sense, competitors.
Meanwhile, Germany had been at war in Europe for more than 2 years. Work on the turbopump and the motor for the A-4 rocket was advancing. They were many times larger than the pump and motor for Dr. Goddard's P-series, and had the potential to power a spectacular weapon.
They generated a very active combustion. So the combustion efficiency of the total A4 engine, the 25.4-ton unit, was quite a bit better than the individual element. And that was an automatic benefit we really hadn't counted on, but that really helped in order to finally meet the military specifications for the A4. Germany has no gasoline, so it was not reasonable to plan for the use of gasoline for the military vehicles. And therefore, von Braun, after studies, came up with the idea to use ethyl alcohol. In Germany, we use potatoes because potatoes were grown plentifully, particularly in the Polish region, and therefore it was no big problem to get ethyl alcohol.
The A4's directional control system used vanes operating in the rocket exhaust. It was similar to Goddard's system, but it had one major improvement. In some versions, the rocket could be cut off from the ground using the best radio technology available to the Germans at the time. By June 1942, the A4 rocket was ready for testing at Peenemünde. It was set up in the main test stand 7. The engine had been proven in static firings. Now many of the people who had first become involved in rocketry back at the Rocket and Flugplatz 12 years before waited for a momentous event. The A4 rocket had enough power to fly to the edge of the Earth's atmosphere. The first tests were not successful. There was still more work to be done.
Von Braun was always very active. He was, of course, observed the launches. He dictated while he was viewing the launch what he saw, what his impressions were. And then, of course, we had staff meetings after the unsuccessful launch, and it was decided what are the changes for the next launch. And that way, finally, on the 3rd of October 1942, we had the first successful launch. Because the V2 had a thrust which was about twice the weight of the V2. So it took off with the same acceleration that you have when you let a stone fall. Dornberger was present. He was very elated. And maybe that was a little bit uncareful of him, he predicted that this day the space age has been born. We have for the first time had a human-built article which went into outer space. At the top of the trajectory, the V2 is almost 100 kilometers, 60 miles high, and most people agree that that is outer space.
Across the Atlantic in Annapolis, Maryland, Dr. Robert Goddard had no idea that one of his great personal dreams was near being realized by someone else in extreme secrecy. The young rocket engineers working with Bob Truax were finding out that Goddard's own reputation for secrecy was well-founded.
See, we were a bunch of kids, and Goddard was the grand old man of rocketry, and we would have sat around his knee and learned rockets if he'd been willing to teach us. But he was very reclusive about rockets. He's a fine gentleman, you know, have you over to his house for dinner, that kind of stuff. Socially, no problem, but he would not talk rockets with us.
After further successful tests, the A4 went into production as a weapon of war. It was renamed the V2, the vengeance weapon. Hitler's attitude to the rocket in early 1943 was difficult to assess, and there were reports that he had a dream about it never reaching London. But Himmler, the head of the SS and the Gestapo, was curious. In 1943, he visited Peenemünde and inspected the facility with apparent interest.
Of course, von Braun's basic idea was always spaceflight, and you may have heard that he once was even jailed for that after the SS tried to get into the picture, and they finally took over the actual production of the V2, as it was called at that time. And they thought, and maybe they wanted to get von Braun out of the way. They wanted to really take over Peenemünde. But they thought that von Braun was spending too much time on spaceflight, on trips to the moon and things like that. And he was not concentrating his talent on the development of the A4 system itself. And only due to Dornberger's very, very active efforts to get them released, he claimed to the highest people in the army, it was still an army operation at that time, that without von Braun, without Klaus Riedel, I cannot do my job, I cannot develop the A4. And so he finally, I think even Hitler had to get finally into the act himself. They were released, first only von Braun and then the others a few days later. And then, of course, the development continued. Maybe this was a lesson to von Braun, and he didn't talk so much about spaceflight anymore.
Von Braun had used the German military machine to help him realize his ambition of space travel. That help did not come free of charge.
It's always seemed to me that it's one of the central sort of ethical dilemmas of science and technology in the 20th century. That desire to achieve a goal that has really important implications for humanity. I mean, leaving the home planet. And what price are you willing to pay to get there?
In September 1944, the V-2 went into operation, using a mobile launching system with success.
And using this launching table on any piece of solid ground, like any street crossing or any somewhat reinforced, even forest walkway, you could launch a V-2. Immediately after launching, the word got around that the V-2 had been launched, and there were normally plenty of people around in the general area who reported that immediately to the British. And then, of course, the British bombers or chase planes took off from the British airports, and about 10-15 minutes later they bombarded the launch site. In the meantime, of course, the troops had folded up all their equipment, which could be done relatively quickly, and they had disappeared and they were at another location.
Production of the V-2 was carried out by Himmler's SS and the Armaments Ministry, and concentration camp prisoners were forced to work in an underground factory near the Harz Mountains under slave labor conditions. Von Braun's moral dilemma became more complex.
It isn't so much the fact that the V-2, for example, was a weapon that killed people on the receiving end, as it is the sort of stunning fact that more people died building it than died on the receiving end.
In Annapolis in the fall of 1942, Goddard's JATO experiments were in trouble.
This final test, it lifted off about 80 feet, and then it overheated, and then sort of, I guess it opened up the chamber a little bit, sort of caused a lot of confusion in the plane, as you would imagine, and but they set it down. There was nothing other than damage to the little bit of the tail section of the PBY. But that ended it, and then Truax, of course, was promoting his acid and aniline unit, and I think they actually fired that several times.
And it was ultimately successful in getting the big PBY, which is underpowered, off the water with not only sizable payloads, we got it off with so much payload that when the rockets quit the engine, the airplane went back down in the water, and it wouldn't stay in the air without it. So we definitely proved the concept was feasible.
In 1943 and most of 1944, American rocket engineers had no idea of the existence of the V-2. But slowly, information began to filter through.
During the war, we were able to get pieces of V-2s that had fallen either in Sweden or in England, and we shipped them back. And at one time, I had a picture of Goddard staring into the V-2 thrust chamber with open-mouthed amazement, because it was so much bigger than any of us had ever built.
He really wanted to work by himself. He refused to release information about what he had done until he was ready to release it.
Charles Lindbergh, Goddard's staunch supporter, summarized his achievement.
Perhaps Goddard's work was a sort of dead end. On the other hand, he was a man who was such a visionary that he didn't have to wait for Apollo to go to the moon. He'd been there in his mind, in his imagination. He had flown into space. He'd lived his life the way he wanted to live his life. And from Lindbergh's point of view, what more can you ask of any human being?
In August 1943, the V-2 facility at Peenemünde was bombed by the Allies, with the objective of not only wiping out the facility itself, but destroying as many German rocket experts as possible. Much of the damage to the test facilities was superficial, but there was great destruction in the surrounding villages. By that time, however, Peenemünde had done its job. The V-2 had developed a life beyond the control of Dornberger and von Braun. At the end of World War II, with Germany defeated, America, Britain, and Russia were all very interested in the fate of the V-2 and in Werner von Braun himself.
The Red Army had shown up, with lists of names and photographs of individuals, von Braun, that they wanted to take home with them, and they were gone. They had gone to the Americans, and that really was not the whole foundation for post-war rocketry in America, but it was certainly a key element.
After the war, captured German V-2 rockets found new homes in Texas and New Mexico. So did Werner von Braun, and more than 100 German rocket scientists who had worked on the V-2 program. The V-2 contributed a great deal to the American space and missile program. Werner von Braun directed high-altitude V-2 firings and worked on guided missile development. Dr. Robert Goddard didn't see the V-2 come to America. He died on August 10, 1945. Less than half a year later, Werner von Braun began work at White Sands, about 100 miles away from the launch site at Roswell, New Mexico, where Goddard had pursued his dream of going to outer space.